Alright, so hello everyone and welcome to this video, and in this video we're going to be talking about how you can solve modern art. We're going to be doing an in-depth explanation for each subtask, so we're going to solve the problem by solving each subtask one at a time and work our way up until we hit the final subtask. And we're going to be doing this in both Python and in C++. So first, we're going to go over the topics we're going to talk about in the video. So first up, we're going to talk about the problem details. So what is the problem? What is the problem about? We're going to give a quick visual representation of the problem. And then after that, we're going to talk about how we're going to solve each subtask. We're going to talk about the algorithm we're going to use, and we're going to implement it in both Python and in C++. So we're going to start with the first subtask, then the second, then the third, and we're going to work our way up until the final subtask where we're going to earn full marks for solving it. So if you need the code used in this video, we're going to put a GitHub link down in the description so you can access the code. And if you want to skip between different sections of the video, we're going to put timestamps in the description so you can do that. And before we start the video, it's going to be nice to know if statements, for loops, and lists, because that's what we're going to be using in this video. If you don't know these already, that's all right. We'll be quickly going over what they are inside the video. So now we're going to go into the problem details. So there's an artist and they have a canvas, and this canvas starts initially black, and they can decide to paint any row they want to and any column they want to. So say they decide to paint this first row. So when they paint this row, any black tiles they paint will turn into gold tiles. So now they decide to paint this column. So if they paint this column, any gold tiles they paint will turn into black tiles. And so that's pretty much the entire problem. And so there are a bunch of subtasks here, and they have different constraints. So in this first subtask over here is worth 1 mark, and we'll be given 1 cell, and there's going to be up to 100 choices by the artist to paint a specific row or column. And in the second subtask here, it's going to be worth 4 marks, where we're going to get 1 row and up to 100 choices. The third subtask, we're going to get a 100 by 100 grid and up to 100 choices by the artist. And for the final subtask, it's going to be worth 5 marks, and there's going to be up to 5 million cells, where there's going to be 1 million choices by the artist. All right, so now we're going to start off with the first subtask, and this subtask is worth 1 mark. We're going to have to keep track of 1 cell, and there's going to be up to 100 choices by the artist on which rows or columns they want to paint. So now here's our 1 by 1 canvas, and something interesting to know is that it doesn't actually matter what the artist says, because if they say, oh, hey, I want to paint across this row, or hey, I want to paint across this column, both of these would result in 1 gold tile. Similarly, if the artist says, I want to paint across this gold tile, or I want to paint vertically across this gold tile, it doesn't really matter because it would result in a black tile. So we can actually simply just count up how many times the artist gives an instruction and then get the final result by just simulating this painting. All right, so now we're going to move on to implementing the first subtask. So first up, we're going to move over to the questions page and see which inputs we need to take in. So we're going to scroll down to sample input 1. And on this first line, we're going to get the amount of rows that are going to be in the canvas. So we're going to do rows equals to input. So this would get the input of the first line, but in order to convert it to a number, we need to put this in brackets and put int. So this would convert whatever's on the first line, which is the input, and we're going to convert that into an integer or a number. So next, let's get the next input. So the next input is this 3, and this is how many columns are going to be in the canvas. So we're going to do cols equals input. And then now we're going to get the input of the third line, which is how many commands or choices the artist is going to give us. So here, the artist is going to paint the first row, and here the artist is going to paint the first column. Now, again, we don't actually need this information because no matter what the artist does, they can pretty much only convert the black tile into a gold tile and a gold tile into black tile. So we actually don't need this input over here. All we really need is how many choices or commands the artist is going to give us. So here we're going to do choices equals int input. So now we're going to need a way to actually simulate the painting from gold to black and black to gold. So
you might have noticed that there's only two states that a tile can really have. It's either black or it's gold. And this is kind of similar to a Boolean type. So a Boolean type has only two different types. So it could be true or false and true. And the states can be represented pretty easily by Boolean. So we're gonna assign a variable current color, which is the color of the current tile, and we're gonna assign that value false, and we're gonna make it so that when the value is equivalent to false, the actual color is black, and we're gonna make it so that when the value is true, the actual color will be gold. So now let's figure out a way that we can flip between black and gold or true and false. So here, to repeatedly flip between the two, we're going to use a for loop. So for I in range choices, and pretty much now we're going to flip between the two by doing current color equals not current color. And pretty much what this does is that, say we have a value of false or black. So what we do is we throw that through not false, which is equivalent to true. And that way, we pretty much make it so that when we have black or false, we turn it into true or gold. So now that we've figured out a way on how we can flip the two, now we're going to move on to outputting the answer. And again, there's two different states that this current color can be. It could be black or gold, and we need to output the amount of gold tiles. So to accomplish this, we're going to create an if statement. So if current color is equivalent to false, so this would be saying if the current color is equivalent to black, we're going to output 0 because there are a total of 0 gold tiles. Otherwise, if current color is true, then we're going to output 1 because there's a total of 1 gold tile. Okay, so now we're going to copy this input and we're going to move it over to the submissions tab where we're going to test our program. Here we're going to change the language to Python. And we're going to paste the code. So now we're going to try and submit. And here, as you can see, the first subtask is over here. So here we have AC, 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 which we in our program passed. So now we're going to move on to solving the second subtask. All right, so now let's move on to implementing the C++ for the first subtask. So first up, we're going to get started with like the base of any C++ program. We're going to do include IOStream, and what this does is it pretty much allows us to take in input and print out output. And next, we're going to create this int main. And pretty much what this does is allow the program to run, and it'll run whatever code you have inside of here. And without this int main, your code doesn't run, so you actually need this. So now let's move on to actually getting the input. So here I've navigated to the modern art page, which is the problem that we're trying to solve. And we're going to scroll down to the sample input over here, and we're going to get this input. So in the first line, it tells us how many rows is going to be on the canvas. So we're going to create a new variable that's going to be a number or an integer called rows. And we're going to do stdcin, which allows us to take in the input rows. And now that we've taken in the input for the first number, let's move on to the second line. So here, the second number says how many columns are going to be in the canvas. So let's create another variable called calls, which is how many columns there are going to be. And we're going to also take in the input for that, calls. And now we actually don't need the rows and calls information because the first subtask guarantees that both of these will be equivalent to 1. But we're just going to read this in so that we can use the information we get from this for later questions or later subtasks. So now let's move on to the third line. And this too says how many choices or how many commands the artist is going to give us. So here the artist is saying paint on row 1 on the first row and paint on the first column. And we actually don't need this information because, again, there's only one tile, so there's not much choice the artist can do. So we really only need how many choices the artist is going to give us in order to determine the final state of the final color of the tile. So we're going to create a new variable called choices, which is how many choices the artist is going to give us. And we're going to also read that in to the program. So now that we've read in all the input, let's move on how we can actually simulate the painting of the tile. So you might have noticed there's only two states the tile can have, or two colors. They can either be black or gold. And now to represent these two states, we can actually use a data type known as a Boolean. And there's only two states a Boolean can have. It can only have false or true. So this is a Boolean is actually pretty nice or pretty convenient for representing these two. So we're going to use one to represent the current color of the tile. So we're going to write bool, which is the type, which is Boolean, bool current color, which is the current color of the tile, and we're going to assign that value of false. So here we're going to try to make it so that whenever this current color variable has a value of false, we're going to make it so that the color is black. And whenever the current color has a value of true, we're going to make it so that the color is gold. So now let's move on how we can actually switch between black and gold. So here we're going to write a for loop here. This is going to be a quick for loop so that we can switch between the two. So pretty much what this is it's a for loop that starts at 0 and it'll count up until we hit the amount of choices. So now we're going to do, inside this for loop, we're going to do current color is equivalent to not current color. And pretty much what this does is it allows us to flip between false and true, and therefore flip between false and black and gold. So let's just say we had an input of false or black. So we would assign current color the value of not current color or not false. And something that is not false is true. So now this would pretty much switch current color from false to true or black to gold. And if we had an input of true and we said not true, then something that's not true is false, and therefore current color would get assigned the value of black or false. And this would pretty much allow us to switch between the two different states. So then now that we figured out how to switch between the two, let's actually make it so that we can output how many golden tiles there are. So we're going to write an if statement saying that if the current color is equivalent to false, that means that there is a total of 0 tiles that are golden, because the only tile that we have is black. So we're going to write stdc out. And what this pretty much allows us to do is print something to the screen. And we're going to write current color. So we're going to print out the current color. Actually, wait, no. We're going to print out how many tiles there are, which is 0. And then we're going to print out a new line character, which pretty much allows this output to end on a new line. And now we're going to write, and then now we're going to reason that if the current color isn't equivalent to false, then the current color must be equivalent to true or gold. And therefore, we can say that there is one golden tile. So again, we're going to write that there's one golden tile, and that there's, and we're going to put that output in a new line. So now let's copy paste this code and move over to submission to check if the code is correct. So now we're going to replace whatever code that they gave us with this code that we just wrote, and we're going to submit it. And here, this is the first subtask over here. So as you can see, we got AC, 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 which means that our program gave the correct answer. And now let's move on to implementing or explaining the algorithm on how to solve the second subtask. So now we're going to move on to the second subtask, which is going to be worth 4 marks, where we're going to have only one row and up to 100 choices by the artist to paint a specific row or column. So here, we can see that unlike the previous subtask where we only had to manipulate a 1-by-1 piece of canvas, we're now going to have to manipulate up to 100 pieces of canvas, which might get a bit difficult to track. So, especially because now the artist can decide to paint at different places along the column. So they could paint here, 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 or beyond. And they could also decide to paint across the entire row, which might get a bit difficult because if the artist has already painted on 1 or 2 tiles along the column, we're going to have to keep in mind which places the artist has already painted so that we can flip the tile from gold to black appropriately. So now let's walk through the quick example and say the artist decides to paint this tile right here. So now the artist has painted into gold. And now let's just say the artist decides to paint along the column. This would get a bit difficult to track because, again, we'd have to keep in mind which tiles we've already painted over so that we can switch it over to black. So now let's move over to the coding. All right, so now let's move on to creating the second subtask for Python. And now, unfortunately, we're going to have to nuke most of this code because instead of manipulating a 1x1 piece of canvas, we're now manipulating up to 100 pieces of canvas. So unfortunately, because of that, we can't use these pieces of code because now, because these pieces of code rely on us having only a 1x1 piece of canvas to function. So unfortunately, we're going to have to nuke that. And we're also going to have to change up how we're going to store the current color because the current colors of tiles could be, say, black, gold, and black. And we can't really represent that by only using one Boolean. So now we're going to have to use multiple Booleans. So we're going to store those multiple Booleans inside of a list with calls items. So say if there were 3 columns, it would fill this current color array or list with black, 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 or false, false, false. And this would allow us to store multiple different colors of different tiles all in one variable named current color. So now let's work on getting the input in simulating the painting. So before we ignored this R1, C1 or choices because if there's only a 1x1 piece of canvas, we don't really need to listen to the artist because no matter what, the artist is always going to do paint on that specific tile. So we didn't really need to listen to the artist before, but now that we have multiple different columns and an entire row that the artist could potentially paint on, we actually need to listen to the artist and simulate their choices. So let's work on getting the input. And something that's more difficult about getting input here is that you can see that the input doesn't end on a new line, so we're going to have some issues with just input, taking in the input. So if we write a for loop to repeatedly take in input real quick for I in range choices, and we say just current information is equivalent to input. If we read in this first line over here, R1, we'd actually get an input of R1, and we can't really manipulate this, and we can't really extract information from this that we can use easily. So now we're gonna create 2 different variables and use a new function or a new way to split the code. So we're gonna take in row call because the first item in here, R or C, determines if the artist is going to paint over a row or column, and we're going to take in the second number as position because that's the position the artist is going to paint at. So we're going to take that and we're going to do input dot split, and what this does is it allows us to split R and 1 so that row or call gets assigned. So that row or call gets assigned the value of R, and position gets assigned the value of 1. So now that we've gotten in the input, we need to actually simulate the painting over the canvas. So let's take care of the easier case where if the row or call is equivalent to C, then we simply just do current color at position -1, which allows us to get the current tile that they're painting on.
So here I realized I forgot to mention why if you subtract 1 from position, you can get the current tile that they're drawing on. So it's because how the problem counts up columns and how Python counts up columns is a bit different. So I'm going to do a quick representation right here. So say we have 3 colors, so you have black, you have 1 gold, and then you have another black here. So how the problem counts up columns here is that it starts from 1, and then it goes to 2, and then it goes to 3. But however, how Python counts up list numbers, it starts at 0, and then it counts up by 1. So in order to convert their counting system over to Python's counting system, we have to subtract 1. So that's why when we subtract 1 from the position, we can get the current tile that the artist is painting on is equal to not current color at position -1. And this allows us to flip whatever's at a specific column. And now let's move on to if the row or column is equivalent to R or row. And this would be a bit difficult now because we'd have to loop over the entire canvas. And we can do this by creating another for loop for, let's just say, j in range calls, so that we can loop over the entire list or canvas. And we can do current color at j is equivalent to not current color at j. And this pretty much allows us to flip whatever's inside the list and flip any gold tiles that we see into black tiles and any black tiles that we can see into gold tiles. And I've actually forgotten to make position a number here, so we're going to do that real quick. Oh wait, position in position. And now we're going to figure out how we're going to output it. So now that we've finished manipulating the painting, we're going to loop over the list once again. So for I in range calls, and we're going to create a new counter here. Gold tiles is 0, and if whatever is at the current color is equivalent to true, which is a gold tile, then we're going to do gold tiles equals gold tiles plus 1, because we found a new gold tile inside of the list. And after we've done counting up how many golden tiles are inside the list, we're going to print gold tiles. And now we're going to copy paste this code, and we're going to see if there are any errors in our program. So here, now we're going to switch to the language to Python, and we're going to copy in the code. And now, as we can see in the second subtask over here, we've got AC, AC, AC. And now that we finished this second subtask, we're going to move on to the third subtask. So now let's figure out how to solve the second subtask using C++. And first up, we're going to have to unfortunately start with nuking a bunch of our code, because these chunks of code relied on the canvas being 1 by 1, which now in the second subtask, it can now potentially be up to 100 pieces large. So unfortunately, these pieces of code, we're going to have to remove them because they relied on the canvas being 1 by 1. And we're also going to need to change how we're going to store the current color of different tiles, because if we had, like, say 3 tiles and they had the color of gold, black, and then gold, we can't really represent all 3 of these tile colors using only one Boolean. So we're going to have to create a list of Booleans in order to represent all 3 of these. So first up, we're going to use something called a vector, and we're going to include it first so that we can use so we can actually use the vector. And basically what a vector is, it pretty much represents like a list of items, or in this case, a list of Booleans or colors. So if I were to put all 3 of these items into a vector, the vector would automatically assign different indexes so that you can, or different numbers to each of the tiles, so that you could look up exactly what color a certain tile has. So if I were to put this all in a vector, they would all get assigned numbers, so 0, 1, and then 2. And then after that, if I want to swap whatever was at, if I wanted to paint over a certain tile at, say, index 0, or aka the first tile, I would do current color at 0 equals not current color at 0. And that would pretty much allow me to flip whatever was at the 0th index to the different color. So in this case, it would allow me to flip this gold here into a black. So now that we've figured out a way to actually store this information, let's work on actually implementing it real quick. I'm going to move this up here first. And now let's change this current color into a vector. So first up, we're going to declare the vector using std_vector. We're going to declare whatever type we're using inside. So this would be a Boolean in this case. And then we're going to declare the variable name, which is current color. Current color. So now let's initialize this vector so that it has a bunch of blacks inside or falses, because that's what the artist starts with. Well, they start with black canvas, so we need to do that as well by pushing in a bunch of falses or blacks. So we're going to create a for loop to do that, to repeatedly push in blacks depending on how many columns there are. So we're going to do that real quick. And now we're going to do current color dot pushback. So this would add an element to the back of the vector. I create it. So just like put up something new at the end of the list, pushback false. And now this line pretty much just adds a new element at the end of the vector and pretty much allows you to manipulate it afterwards. So now that we've actually created the vector containing a bunch of falses or blacks, let's work on getting in the input. Now, before, during the first subtask, we ignored these two inputs, R1, C1, because if the artist only has a 1x1 grid, there's only one choice they have, and that's to change whatever's at that 1x1 grid. Now, unfortunately, with this second subtask, this is not the case anymore, because now the artist has multiple different choices they can take. For example, they could paint at a specific column, or they could also paint over the entire row. So now we need to actually listen to what the artist says so we can actually implement an algorithm and simulate the painting. So we're going to do that by first actually getting the input. So we're going to have to declare two new variables here. One's going to be whether it's going to be a row or a column, and one that's going to store the position of wherever the artist is painting. So let's do that. So I'm going to create a new variable, car row or call, which is going to store this first letter here. So this first letter determines if the artist is painting at a row or a column. And after that, I'm going to create another variable, which is going to be a number. So int position, which is going to determine the position the artist is going to paint at. So now let's repeatedly get the input and then manipulate this current color vector. So we're going to repeatedly get input here using using a quick for loop. And now we're going to do stdcn to get an input, row or call. And we're also going to take in position while we're at it. And now let's actually work on manipulating the current color vector. So we're going to start by checking if the artist is painting over a row or a column. And let's work with the easier case where the artist is painting over a column. If row or call is equivalent to C. Now, if the artist is painting over a specific column, all we need to do is, again, before index, wherever that specific color is, or wherever the position is, and then change that so that it's not whatever it is currently. So let's do that real quick. So current color at position -1 equals not current color position -1. And the reason why I'm doing -1 here is because these vectors, they start
assigning numbers to elements when they're at 0, and and the canvas starts assigning at 1. So unfortunately, they're a bit different. The number systems are a bit different, so we had to subtract 1 from their numbering system to get the corresponding index in our system. So here, so say they wanted to flip the first number, so position would be equal to 1. So that'd be 1 minus 1, 0, not 1 minus 1, which is 0. So it pretty much just flips whatever is at our first index. So that's what it does. And now that we completed the case where the artist is manipulating a column, now we're going to need to work on the case where the artist is manipulating a row. So now we're going to add an else statement, because if the rower call wasn't a C, therefore the artist must have been painting over the entire row or the entire vector. So we're going to create another for loop inside here for int j. And this for loop is going to be used so that we can loop over the entire vector and flip golds into blacks and blacks into golds. J++. And here we're going to repeatedly loop over it. So we're going to do current color equals not current color at j. So this is again going to invert. I'm going to loop through 1 by 1. So it's going to loop whatever is at element 0, going to flip it to its opposite value, and it's going to do that for each of these indexes: gold, gold, black, and that's pretty much what it's going to do. So now let's. So now that we've finished manipulating the elements, we're gonna need to keep track. Now we're gonna need to find how many golden tiles are inside the vector so we can output a response. So we're gonna create a new variable int gold tiles. I'm gonna assign an initial value to 0, and now we're gonna loop over the entire vector again. And then if whatever's at the current position is equivalent to true, then we know that this whatever's at this position is a golden tile, because again, true corresponds to gold. So we're going to do gold tiles plus 1 equals gold tiles plus 1, because again, we're just repeatedly adding if the current color is a gold tile, if whatever is at the current position is a gold tile, we're just going to add 1 to the gold tiles. And after we're done adding up the gold tiles, we're going to quickly output the counter, how many golden tiles that we counted up. So we're going to std cout gold tiles, and we're going to add a new line character. And now we're going to copy paste our code and see if this code is correct. So I'm going to open up the submissions tab, submit tab, going to paste the new code in, and we're going to see the results of the code. So as you can see here, this is the second subtask. We got AC, AC, AC. So our program was correct, and now we can move on to solving the third subtask. So now we're going to be talking about the third subtask. It's worth 5 marks, and the constraints are there's going to be up to 100 rows, 100 columns, and there's going to be up to 100 choices by the artist to paint over a specific row or column. So now, unlike the previous subtask, instead of just having 100 in this direction, we're also going to have 100 in this direction, which could complicate the way we store the data and the way we change the data and the way we simulate the painting. So for example, if we painted these 2 rows, now they're all gold, and if we painted this column, we're going to have to, instead of just inverting 1 tile, we're going to have to invert the entire column, which again, it's going to be a bit difficult to actually create the algorithm for it, to actually implement it. But other than that, it shouldn't be too different from the algorithm that we've already designed. So let's move on to coding. All right, so now let's work on coding this Python solution for the third subtask. So we're going to have to nuke a good chunk of this code here because now we're dealing with multiple rows, so unfortunately this piece of code has to go, but we can keep the code that we're using to get the input, and we're also going to nuke this piece of code because now there are multiple rows. And we're also going to need to change the way that we're going to store the elements inside of current color, because now that there's multiple rows, having only one row isn't going to cut it. So we're going to have to create multiple rows. Now recall, this is the way that we use to create an entire row of falses or blacks. So we're going to take that code and put it inside a for loop so we can repeatedly add rows into current color. So here, this is just saying current color is going to be a list. And now let's actually add the elements into current color. So we're going to create the for loop for I in range rows, because that's how many times we want to add new row into current color. And we're going to do current color dot append false multiplied by calls. And what this append does, it is pretty much adds something to current color. So in this case, it adds an entire list or row of falses or blacks. And once we're done adding that, we can move on to manipulating it. But first, let's figure out how we can actually manipulate it. So say we had inside current color, we had black, gold, and we had gold, black. So this would be the first row, this would be the second row, and after that, this would be the first column, and this would be the second column. So this column would have value 0, this row would have a value of 1, this row would have value 0, this row would have a value of 1. So now let's move on how we could say maybe switch the value of this item to its opposite color, which is, in this case, is black. So first up, we're going to start by indexing the row that this element is at. So we're going to say current color at element 0, and this would return a list of black and gold. This would return these specific elements. And now, since this is a list, we're going to have to index this list to get our specific element. So we're going to have to put an index of 1 because that's where the gold, where this gold lies. And now we're going to invert it. So we're going to do current color at 0 at 1 on the 0th row on the first column is equivalent to not whatever's at the 0th row in the first column. And now that's how we would go about inverting something inside current color. So you first index using the row number, and then you index using the column number. So with that in mind, let's create the code for actually manipulating. The current color list and painting. So now let's determine if the artist wants to paint over a row or column. So we're going to include an if statement here. So if row or column is equivalent to R, then we know the artist is trying to paint over a row. So now that we know that, we're going to create a for loop to loop over the columns inside of that row. So we're going to create a for loop here for for j in range calls, because we're looping over the columns. We have a row, and we're inside that row, we're looping over the columns. And after that, we're going to do, to index it, we're going to start by getting the row number, which in this case would be position, because since the artist wants us to loop over a specific row, the artist has given us the row number that they want to loop over. So here we're going to start by indexing with the row number, aka position, and then after that we're going to index using the column number, which is j, and it's the counter. And now we're going to invert whatever is at this, whatever is inside this spot at current color, and that's how we're going to invert. And that's how we're going to invert an entire row of items. And we can do something similar for columns. So we're going to put an else here, and now we're going to create a for loop to loop over all the rows given the column. So we're going to do for j in range rows, because we're looping over rows here. We're going to do current color and we're going to index using the row number. In this case, it's going to be J because that's what we're going to be counting. And then now we're going to index with position because that's what the artist has given us. The artist has given us the column number that they want us to change. So current color, J, and then to invert that, we're going to do equals not whatever is at there. So that's how we're going to manipulate and simulate painting. So now that we've done that, let's figure out a way to count how many gold tiles are there after the artist is done painting. So we're going to create a new variable here, gold tiles equals 0. And now we're going to loop through the current color grid or list in order to count up. So if we're going to do for a row in range rows, and then we're going to do for call in range calls. And basically what we're going to do here is we're going to loop through the rows, and we're going to inside that we're going to loop through the columns inside of the row, and that's where we're going to check whether the current tile is a gold tile or not. So we're going to do if current color at row at column is equivalent to true, which means that it's equivalent to gold because true corresponds to gold here. We're going to do gold tiles equals gold tiles plus 1 because we found a gold tile, and we're going to add one gold tile to the current counter. And after that, we're going to print out the amount of gold tiles. So now let's copy paste our code over, and we're going to try and submit and see if we got the correct answer. We're going to switch our language to Python. And now we're going to submit it, and hopefully we get AC. And unfortunately here you can see that we're getting index error. So let's find out what's going wrong inside of our program. So index error usually means that we're accessing a list element that's out of bounds. So let's just take a quick example here. So let's just say we have black, gold, and gold, black. So index error usually means that I'm accessing something that's out of bounds. So maybe I accidentally accessed whatever was here. And unfortunately, since it doesn't exist, we get index error. So now let's figure out what's happening and where this index error might be coming from. Now, I'm going to take a guess here and say that the index error is coming from somewhere inside here. So let's look inside here. And something that I've noticed right away is that since they count positions differently, their positions counter starts at 1, whilst our list position counter starts at 0. We're going to need to subtract 1 from position so that we can convert their counting system over to our counting system. So now let's submit this code, and hopefully we get the correct answer. Resubmit. And here, as you can see, we're getting AC, AC, and this is our current third subtask. We get AC, AC, which means our program passed, which is good. And now let's take a quick peek at what the next test case is. And now instead of getting the wrong answer, we're actually exceeding the time limit. So now we're going to need to find a way to optimize our program so that it runs faster. So now we're going to move on to talking about how we can optimize our code for the next subtask.
All right, now let's work on implementing the solution for the third subtask in C++. So first up, we're going to remove a good chunk of our code here because these pieces of code relied on us only having 1 row, and now that we could have up to 100 rows, we're going to have to remove this code because it's no longer relevant. We're also going to have to remove this code because, again, this code is no longer relevant because now there could be more than 1 row at a time. And now we're also going to need to change how we're going to store the colors of the different tiles on the canvas, because say we had this canvas over here. So we had gold, black, and we have on the second row black and gold. We can't really store this using our current storage mechanism, which can only store 1 row. So what we're going to do is we're going to create another vector to store multiple different rows. So how this would work is if I wanted to index this specific element over here on the 0th row on the first column, what I would do is I would write current color, write some square brackets, and write the row index that I want to index here. In this case, it'd be 0 because it's on the 0th row. And I would write the column index that I want to get, which is 1 in this case. And that would allow me to get this something on this column. And in this case, it was black because it's the element on the 0th row on the first column. And now if I wanted to invert this, I could do not current color. And that's how I would invert something that's already there. And that's how I would switch between black and gold at a specific element. So now that we figured out how we can index and switch specific elements, let's figure out a way so that we can actually represent this and initialize it. So we're going to need to change how we're going to create our current color. So recall that this is the code that we're going to use to create a row. So we're actually going to make a new variable real quick here called oneRow. And this is going to store the contents of one row. So this would store an entire row of just blacks or falses. So instead of pushing current color, instead of pushing black to current color, we're going to push it to one row. And after that, now that we created one row, we're going to create another for loop. And what this is going to do is it's going to create a bunch of rows, and it's going to add a bunch of rows to the current color. So now we're going to do current color dot pushback one row. And so that's how we would add multiple rows to current color. So now that we've found a way to represent current color, let's work on actually carrying out the artist's orders and painting over certain rows and columns. So now we're going to piggyback off the code that I've already written here. And now we're going to need to handle different cases where the artist could be painting over a different row or a different column. So first, we're going to take care of the case where the artist wants to paint over a row. So if row call is equal to R, that means the artist is painting over a row. So now, in order to manipulate an entire row, we're going to need to create a for loop. And what this for loop does is pretty much it loops over one row with this amount of columns. So now we're going to find a way to index the current color like we've done here. So we're going to write current color. And now we're going to input the row index. And since the artist is telling us to paint a specific row, they've actually already given us the row index here. So we're going to put position as the row index. And now since we're looping over a bunch of columns, we're going to put J as the column index because that's what J is for. It's for looping over different columns. So now we're going to copy paste this and we're going to write equals not whatever is already there. So that's how we would loop over a row. So now we're going to work on looping over a column. So again, we're going to write a for loop here so that we can loop over multiple rows. So since we're given the position of the column, now we just need to loop over all the rows and change the index at the specific column that we were given. So here we're going to write current color at J. And we're writing J here because J is the row index. The artist has already given us the column index for the position, so that's what we're going to be indexing next. And now we're going to write equals not whatever is already there. So that's how we would paint and simulate painting of a specific column. So now we're going to remember to write position equals position -1 because basically, how they count up rows and columns, they start at 1, 2, 3, and 4, and so on. But however, our vectors start at 0. So we're going to need to convert position and shift it over by 1 so that we can shift this, so we can shift their columns and rows into our way of counting columns and rows. So now that we figured out how we can simulate painting over the different rows and columns, now we're going to need to figure out a way that we can count up the amount of golden tiles inside the entire vector. or the entire current color. So to do that, we're going to write a for loop here. And this for loop is going to be in charge of looping over the rows. And then inside of this for loop, we're going to write another for loop, which is going to be in charge of looping over the columns of that specific row. And then now inside of here, we're going to write an if statement to check if the current element that we're accessing is a golden tile. So we're going to do this by, so how we're going to index it is we're going to do current color at the row index, which in this case is row, and then at the column index, which in this case is col. So we're going to write an if statement to check if this, whatever is here, is a golden tile. So we're going to write if current color at row at column is equivalent to true, which again means that true is gold. So that means if the tile is gold, then we're going to increase the golden tiles counter by 1. And that's how we're going to sum up all of the golden tiles inside of this current colors vector. So now we're going to copy paste our code and submit it and check if we have any issues with our program. So this is the third subtask right here. So as we can see, we got AC and AC, which means our program has passed, which is good. And we're just going to take a sneak peek of what issues we're having on the last subtask. And we're actually exceeding the time limit instead of getting the wrong answer this time. So now we're going to need to figure out a way to optimize our code so that our code can run faster and pass the new larger test cases. So now let's move on to talking about how we can solve the final subtask. So now we're going to move on to solving the fourth subtask, which is going to be worth 5 marks. And if we're able to solve this subtask, we're going to get a total of 15 out of 15 marks. And in this subtask, we're going to get up to 5 million cells that we're going to have to keep track of. And there's going to be up to 1 million choices by the artist to paint over a specific row or column. So now, these grids can get pretty large. They can have up to 5 million rows or 5 million columns, which is a lot to keep track of. And now we're going to need to find any optimizations that we can make so that our program can handle these larger grids without exceeding the time limit. So in order to find those optimizations, we're going to move to a slightly smaller grid in comparison, a 9x5 grid. And we're going to be taking in a sample input, and we're going to be simulating that sample input and seeing if we can find any optimizations that we can make. So now that we have this sample input, pause the video and try to find any optimizations, or maybe even try to find a pattern that we can use to find the amount of golden tiles inside the canvas a bit quicker. So one of the more apparent optimizations is that if an artist paints over a specific row or column twice, they actually cancel out, so we don't need to keep track of that. So now, given this new input, maybe try to find a pattern that we can use so that we can find the amount of golden tiles inside the canvas a bit quicker. So let's take this one step at a time and paint over the rows first. Now, given this new input, try to find a way that would allow us to find the amount of golden tiles inside of the grid a bit quicker. All right, now that we simulated that, this is what our grid would look like after we painted over the columns. And you might have noticed that 2 of the golden tiles turned black and 3 of the black tiles turned gold. So we can actually use a formula to calculate this. So we can use the formula new golden tiles equals rows of black. So for example, we notice that 3 of these black tiles turn into gold. And whenever our artist paints over a black tile, it's going to turn gold. So we're just going to keep track of 3 black tiles will turn into gold. So that's what rows of black is. And then we're going to subtract that with how many golden tiles is going to turn into a black tile. So over here, we notice that 2 of these golden tiles are going to turn into black tile if the artist decides to paint over the column. So we're going to do rows of black. So we're going to do the amount of black tiles that are going to turn into gold tile minus the amount of gold tiles that are going to turn into black tile. So if we look back at our example, we have 3 rows are black, So we have 3 minus the amount of rows of gold, which is 2. So we're going to do 3 minus 2, which is going to give us 1 new golden tile every time we paint over a specific column. And let's just double check that. So first up, we have 2 golden tiles inside of this column, and we should get 1 extra golden tile at the end of the painting. And as we can see, now we have 3, so our formula is correct. And now we can move on to changing up how our algorithm tracks the grid. So now, instead of tracking the entire grid, we can actually just track whether or not the artist has decided to paint over a specific row or column. And we could use that information, and we can also use the formula that we talked about before in order to find the amount of golden tiles. So if you were to try to keep track of the golden tiles when we're painting over a row, that's pretty simple. All we need to do is just add the specific, add all the columns that are inside of the grid. But if you want to paint over the columns, we can just simply use the formula new golden tiles equals rows of black minus rows of gold. And we can simply use that formula to keep track of how many new golden tiles there are if we paint over a specific column. So we can just simply add up the amount of golden tiles that were generated by painting over the rows, and we can use this formula to simulate the painting of the columns to get the final amount of golden tiles inside the canvas. So now let's move on to implementing that. So now let's work on implementing this in Python. And the first thing we're going to do is we're actually going to nuke a bunch of our code because this code relied on us storing the grid differently. Before we were storing this as an actual grid, and now we're just going to store 1 row worth of commands and 1 column of commands. And since that's changing, we're going to have to nuke a bunch of that code because it's no longer relevant. And we're also going to need to change how we're going to store the commands. So we're going to use 2 different lists to store the commands. We're going to call one of these paint row, which is going to tell us if the artist wants us to paint over a specific row. And we're also going to create another list called paint call, where it's going to tell us if the artist wants us to paint over a specific column. And how are we going to store the different states? Well, we could use a Boolean again, and we're going to initialize this to false. So we're just going to say if it's false, then that means the artist doesn't want us to paint over that row or column. But if it's true, then they want us to paint over that specific row or column. So we're going to initialize all of this to false, so the artist doesn't want to paint over it. And as we get an input, we're going to change the elements inside here. Multiply that by the amount of rows, false, and then multiply that by the amount of columns. So now that we figured out a way to store if the artist wants us to paint over a specific row or column, let's actually get the input. So just a quick recap on how we got input before. If we scroll down to the sample input, first they'll give us how many choices the artist will want to give us, and then first in the first thing there, they'll give us whether or not the artist wants to paint over a specific row or a column, and then after that they'll give us the position of that row or column. So let's work on getting the input for that. So we're going to declare so first we're going to create a for loop to get the input. And now that we've done that, let's work on getting the input. So first up, the first variable is going to be row or col. It's just going to store whether or not whether the artist wants us to paint over a row or a column. The second variable will be the position of the row or the column the artist wants us to paint over. We're going to take the input and we're going to split it again, so that the row or col goes into here, the R or the C goes into here, and the position will go into there. So now what we're going to do is we're going to convert position into a number. And we're also going to subtract 1 from position. The reason being that how they count up rows is different from how we count up rows. So they count up rows using 1, 2, 3, and 4. You know how people count. And however, how Python counts it, the list is they start from 0, and that's a bit different from their system. So in order to convert their system of counting into our system of counting, we're going to have to subtract 1 from the position. So now that we've done that, let's take care of the cases where the artist wants us to paint over a specific row or column, and we're going to simulate that. So we're going to take if row or column is equivalent to the row, then that means the artist wants us to paint over a row. And now we're going to index paint row. get the position, and we're gonna make it so that it's not whatever's at there already. And what this does is it's similar how we converted it from gold to black in previous examples. Except now we're just storing whether or not they want us to paint. So for example, if the artist wants us to paint over a specific row, we'll take the input over here, and then we're going to change it to what is not there. So in this case, start at false, so not false is true. So now turn it to true. But if the artist wants us sends another command to paint over that specific row again, we can actually negate that by using this again, and that would turn not true, and that would turn it into false. And that's how we would handle multiple inputs, and that's how we would eliminate the times when the artist wants us to paint over a specific row multiple times. And now we're going to do the same thing for columns. So otherwise, if the row call isn't equal to R, that means they want us to paint over a column. And we're going to do paint call at that position is equal to not whatever's already at that position. So now that we've finished getting the input and manipulating whether or not the artist wants us to paint over a specific row or column, let's work on calculating the amount of golden tiles that are currently in the grid or the canvas. So we're gonna create a counter here to keep track of how many golden tiles are that we found so far. And how we're gonna calculate the amount of golden tiles is first we're gonna simulate painting over the rows, and we're gonna ignore the columns at that point. And then after that, once we're done painting the rows, we're gonna paint over the columns, and we're gonna use the formula new golden tiles is equivalent to rows of black minus rows with gold in order to find the new amount of golden tiles that we got. So now let's work on that. So first up, we're going to create a for loop to loop through the paint row commands and add the amount of golden tiles to our golden tiles counter over here. So we're going to create a for loop to loop through the paint row list. And now we're going to check if that specific index says yes, the artist wants us to paint over it. So if paint row at this position is equivalent to true, which means the artist wants us to paint over it, we're going to add the amount of columns. We're going to add the amount of columns to this. So we're going to do gold tiles equals gold tiles plus calls, because that's how many tiles that they're painted over. When you're painting over one row, you're going to paint Call's amount of black tiles gold. So that's how we're going to paint over the rows, and that's how we're going to keep track of how many golden tiles there are after we painted the rows. And now we're going to need to keep track of how many new golden tiles we get from painting over the columns. So we're going to create a new variable, new gold tiles, so that we can keep track of how many new gold tiles we get inside of the loop. So now we're going to do for I in range calls, and we're going to loop over the paint call list. And now we're going to check if the artist wants us to paint over an index over the column at a specific index. So we're going to do if paint call at position I is equivalent to true, which means the artist wants us to paint over it. We're gonna use this formula over here to calculate the new amount of golden tiles that we're gonna get. So we're gonna do new golden tiles, but now we need to find how many rows have black and how many rows have gold. And to do that, we're gonna backtrack a little bit here, and we're gonna declare these two variables over here. And while we're checking while we're counting out the amount of gold tiles, we're also going to count out how many rows have black and how many rows have gold. So now if the artist succeeds at painting, then that means the amount of rows of gold increases by 1. So we're going to take care of that. Otherwise, if that doesn't happen, we're going to increase the counter for the amount of rows of black by 1. All right, so now that we updated it, and we can now use these two numbers inside of our calculation. So we're going to do new gold tiles equals rows of black minus rows of gold. And we're going to add the new amount of gold tiles to the gold tiles counter. So we're going to do gold tiles equals gold tiles plus new gold tiles. So now that we've calculated the amount of gold tiles, we're going to print out how many gold tiles that we found. And now we're going to copy paste our code and we're going to submit it. So here now this is the final test case. We get AC, 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 and now that we passed these cases, we finished this question, and now we have 15 out of 15 marks. All right, so now let's work on solving the fourth and final subtask in C++. And now since we're changing up how we're storing up the information, so instead of storing up a huge grid, we're just storing up one row worth of commands and one column worth of commands. So now we're going to nuke this code because it's no longer relevant, since now instead of using a grid, we're using one row worth of commands and one column worth of commands. So now we're going to switch how we're going to store the information as well. We're going to use one vector to store the amount of the commands for one row. So we're going to call this paint row. And we're going to use another vector to store the commands for if the artist wants us to paint a specific column. So now that we've done that, let's discuss what bools actually, what we're going to use this Boolean type for. So basically, we're going to use this Boolean type. So if the Boolean inside here is false, that means the artist doesn't want us to paint over that specific row or column. And if the Boolean inside there is yes or true, that means the artist wants us to paint over the specific row or column. So that's how we're going to store if the artist wants us to paint over a specific row or column. So now let's actually initialize these two vectors. So we're going to create a for loop here. And inside this for loop, it's going to count up until we hit the amount of rows. So while we're doing that, we're going to do paint row dot pushback false. So what this pretty much does is it pretty much allows us to add a new row, and inside that row, it'll store whether or not the artist wants us to paint over that specific row. So now let's create another for loop to add a new column into paint call. So now that we've done that, we're going to do paint call dot pushback false. All right, so now that we've done that, let's figure out a way that we can actually get the input and simulate and actually store the inputs of the painting. So let's review back for what the input is. So we're going to scroll down here and we're going to see this is the amount of choices or inputs the artist is going to give us. And this first letter over here stores whether or not the artist wants us to paint over a row or a column. And the second number over here stores which position or which row or column number the artist wants to paint at. So we're going to declare two new variables to store this. The first variable is going to be a character or a letter. That's going to store if the artist wants us to paint over a row or a column. And then the second input is going to be integer or a number, which stores the position the artist wants us to paint at. So now that we've done that, let's create a for loop to get the input. So now that we create the for loop to get the input, inside here we're going to get the input using stdcn, which is what we're going to use to take an input, row or call. And then after that, we're going to take in the position. Then now we want to subtract 1 from position. And the reason is how they store numbers and how they store rows is a bit different from how we store rows. So how they store rows is they start from 1, they start counting from 1, and then they go up 1 at a time. However, how vectors store items is that they start from 0 and they count up 1 at a time. And in order to convert their method of counting into how a vector counts up, we're going to need to subtract 1 from position. So now that we've done that, we're going to store the information on which rows and columns the artist wants us to paint at. And to do that, we're first going to use an if statement to check whether the author wants us to paint at a row or column. So if row or column is equivalent to R, that means the artist wants us to paint at a specific row. So then we're going to index this paint row, and we're going to do paint row at I is equivalent to not paint row at I. And this is going to allow us to handle cases where the artist wants us to paint a specific row more than once. So pretty much this paint row at position I will start with false. And if the artist wants to paint it once, it'll turn not false into true. Not false into true. And that's going to, so that's how we're going to store if the artist wants us to paint at a specific row. But if the artist wants us to paint at that row again, it's going to turn not true into false. So that's how we're going to negate situations where the artist wants us to paint at a specific row more than once. So we're going to do a similar thing for when the rows or columns is C, or the artist is telling us to paint at a column. We're going to do paint call at position I equals not paint call at position I. So now that we've done that, we're going to move. Now that we've done that and we've finished simulating the input, we're going to move down and try to calculate how many golden tiles are in the canvas or the grid at the end of all this painting. So first up, we're going to declare a variable called gold tiles, which is going to store how many golden tiles that we've counted up so far. And now we're going to loop through paint row to check if the artist has painted over a row. And if the artist has painted over a row, we're going to add the amount of rows. So let's just quickly write that down. So we're going to first check if the artist has painted over the specific row. And after we're done checking that, we're going to check if the artist wants us to paint over a column. And if we do, and if the artist does want to paint over a column, we can use the formula that we discussed earlier. So that'd be new gold tiles is equal to rows with black minus rows of gold. And we're going to be able to use this formula. We're going to be able to use this formula to calculate how many gold tiles we get when we paint over a specific column. So now first let's add up the gold tiles we get from painting over the row. So we're going to create a for loop here. And inside this for loop, we're going to index paint row. So and check if the artist wants us to paint over a specific row. So we're gonna do if paint row at this position I is equivalent to true. That means the artist wants us to paint over that row, and we're gonna get a bunch of golden tiles because of that. So then we're gonna do gold tiles equals gold tiles plus calls, because in one row there's gonna be calls amount of black tiles that are gonna be converted into gold tiles. So now that we've done that, let's work on adding and simulating when the artist paints over columns. So now, in order to do that, we're going to implement this formula. So first up, we're going to create a for loop to loop over paint call, like we've done with paint row over here. So we're going to do for int I equals 0. We're going to create a for loop real quick. And inside of here, we're going to say if paint call at position I is equal to true, that means they want us to paint over this specific column. We're going to have to implement this formula, but however, we're missing a bunch of information. We're missing how many rows have black and how many rows of gold. So now we're going to backtrack a little bit, and we're going to declare these variables up here. And how we're going to extract this information is when we're looping through the paint row, we're gonna keep track of how many rows now have gold and how many rows now have black. So if the artist wants us to paint at this specific position, that means they're gonna change all the black tiles into gold tiles. So now we're gonna have an increase of gold tiles. So now we're just gonna increase rows of gold by 1 here. But otherwise, if they don't paint there, that means there's one black row. So we're going to increase rows of black by 1. So now that we found out this information, we can actually implement this formula down here. We're just going to declare a new variable to store the result of the formula real quick here. So new gold tiles. So now we're going to actually implement the formula. So we're going to do new gold tiles equals rows of black minus rows of gold. So that's how many new golden tiles that we've got. So now we're going to add this new gold tiles into our golden tiles counter. So we're going to do gold tiles equals gold tiles plus new golden tiles. So now that we finished getting how many golden tiles are inside the entire grid, we're going to print that to the screen. So we're going to say stdc out golden tiles. And then we're going to add a new line character so the output ends in a new line. So now we're going to copy paste the code and submit it to check if it's correct. So unfortunately, we're getting WAS, and RTE aborted. So we're going to have to figure out what's happening here. So let's review the code real quick. All right, so we're back, and after debugging, it seems like this code over here is actually incorrect. So we're only using I here as a counter to take an input, and we should actually be using position to index these specific spots instead of. All right, so we're back, and it seems like in this for loop here where we're getting input, it seems like we're using I to get input, when I is only used to loop through the inputs and get the inputs itself, and it's not really supposed to be used for indexing paint row or paint call. So instead of using that, we're gonna be using position instead to index these. And now that we're done that, let's copy and paste this code and submit it and see if we get the correct answer again. So here we got AC, 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 and AC, which means our program passed. And now we're done with this question, and we got 15 out of 15 marks.